Our story begins billions of years ago. Imagine a vast cold cloud of gas and dust drifting through space. This is a nebula, the birthplace of stars. Gravity, the architect of the cosmos, slowly draws this cloud inward. The particles collide, generating heat. As the cloud collapses, it spins faster and faster like a skater pulling in their arms. The center becomes incredibly dense and hot. Temperatures soar to millions of degrees. Finally, nuclear fusion ignites. Hydrogen atoms fuse into helium, releasing a tremendous amount of energy. Our sun, a brilliant star, is born. It bathes the surrounding disk of leftover gas and dust in light and heat. This marks a pivotal moment in our cosmic history. The stage is set for the formation of planets, including our own Earth. The leftover material from the sun's formation swirls around the newborn star. This disk, composed of gas, dust, and ice, is where Earth will take shape. Tiny dust grains drawn together by electrostatic forces begin to clump. These clumps, called planetesimals, grow larger over time. They collide and stick together, gradually increasing in size. The process, known as accretion, continues for millions of years. Earth, still in its infancy, is a growing ball of rock and metal. As Earth grows, its gravity strengthens. It attracts more and more material, pulling in planetesimals like a cosmic vacuum cleaner. The planet's size increases dramatically. The early Earth is a hot and violent place. The constant bombardment of planetesimals generates immense heat. Radioactive elements within the Earth decay, releasing even more energy. The intense heat melts the planet's interior. Iron and nickel, being denser materials, sink towards the center, forming Earth's core. Lighter materials, like silicates, rise to the surface. Volcanoes erupt across the young planet, spewing molten rock and gases into the atmosphere. The Earth is a fiery inferno, its surface a churning sea of magma. But amidst this chaos, the seeds of our planet's future are being sown. Shortly after its formation, Earth experiences a cataclysmic event. A Mars-sized object named Theia collides with our young planet. The impact is colossal. Debris from the collision, a mixture of Earth and Theia material, is ejected into space. This debris, bound by gravity, coalesces over time, forming our moon. The moon's formation has a profound impact on Earth. Its gravitational pull stabilizes Earth's axis of rotation, creating the regular seasons we experience today. The tides, driven by the moon's gravity, also play a crucial role in shaping our planet's coastlines. As Earth cools, water vapor in the atmosphere condenses. Torrential rains fall upon the cooling surface, filling the planet's basins. The first oceans begin to form. The source of Earth's water is a subject of ongoing scientific debate. Some scientists believe that water was delivered to Earth by comets and asteroids during the early bombardment period. Others theorize that water was present in the Earth's building blocks from the very beginning. Regardless of its origin, the presence of water is a defining feature of our planet. It sets the stage for the emergence of life. The oceans become the cradle of the first life forms on Earth. The early solar system is a chaotic and crowded place. Countless asteroids and comets, remnants from the planet-forming process, hurtle through space. Earth, still in its formative years, is bombarded by these celestial objects. The impacts are devastating. Asteroids, some miles in diameter, slam into Earth with incredible force. These impacts release massive amounts of energy, vaporizing rock and creating enormous craters. While these impacts are destructive, they also play a vital role in shaping Earth. Asteroids and comets are believed to have delivered water, organic molecules, and other essential ingredients for life to our young planet. Deep beneath the ocean's surface, a different kind of environment exists. Hydrothermal vents, fissures in the Earth's crust, spew superheated water rich in dissolved minerals. These vents are teeming with life. Chemosynthetic bacteria, able to convert inorganic compounds into energy, form the base of the food chain. They thrive in the harsh conditions around the vents, independent of sunlight. Scientists believe that hydrothermal vents may have been the birthplace of life on Earth. The unique chemical reactions occurring around these vents could have provided the building blocks and energy sources necessary for the first life forms to emerge. Life finds a way. The first microbes. In the warm, nutrient-rich waters of the early oceans, life emerges. Simple, single-celled organisms, the first microbes, appear. These prokaryotic cells lack a nucleus and other complex structures found in later life forms. These early microbes are incredibly successful. They reproduce rapidly, their numbers exploding in the primordial seas. They evolve and diversify, adapting to different environments and resources. The emergence of life marks a pivotal transition in Earth's history. Our planet is no longer a barren rock but a living world. The stage is set for the evolution of more complex and diverse life forms. The oxygen revolution, a breath of fresh air. A new type of microbe, cyanobacteria, evolves in the Earth's oceans. These remarkable organisms possess the ability to perform photosynthesis. They use sunlight, water, and carbon dioxide to produce energy, releasing oxygen as a byproduct. Oxygen, toxic to many early life forms, begins to accumulate in the atmosphere. This triggers a dramatic shift in Earth's environment. The oxygen revolution paves the way for the evolution of oxygen-breathing organisms. The rise of oxygen also leads to the formation of the ozone layer, a protective shield that absorbs harmful ultraviolet radiation from the sun. This allows life to colonize land, forever changing the face of our planet. From stardust to us. From a swirling cloud of gas and dust, a star is born. Around that star, a planet forms, enduring a tumultuous youth of volcanic eruptions, asteroid impacts, and the birth of its moon. In the planet's oceans, life emerges, simple at first, but destined for complexity. The journey from stardust to life on Earth is a testament to the power of natural processes unfolding over billions of years. It is a story of cosmic collisions, chemical reactions, and remarkable adaptations. Today, as we marvel at the diversity of life on Earth, we are reminded of our profound connection to the cosmos. We are, after all, stardust ourselves, products of this epic journey from a cloud of gas and dust to a living, breathing planet.